Yep. Okay, so let's begin. So, guys, as I said, I haven't said anything actually. Let's begin. This week, we're gonna talk about observability in Kubernetes. Of course, many of you guys know the actual meaning behind observability. It's basically Prometheus and Grafana. Hello, Shad. Thank you for joining.
هاي مايا سوري بس كان في عندي هيك a little bit of problem with Ubuntu, so
Yeah,
I was trying to fix it.
I understand. تصير بأحسن العائلات.
100.
So, guys, as I said, Shahad will be doing the practical part. He's an organizer as well in CNCF Jordan. And we will have it in index, I think, 7 and 8. So, also before we start, this is a huge, huge, huge disclaimer that this is meant for Kubernetes month. So, observability is for Kubernetes. We're not going to be talking about observability in general. Maybe I'm going to make a month for observability alone. But as I said, disclaimer, this is observability in particular and Kubernetes. So let's start. Our table of index, we're gonna start by saying or talking about what is observability and why it's more important than monitoring. Maybe it's not more important. We're actually gonna have a small discussion. Is it actually more important, or are they both like help each other, or all of that? And we're gonna talk about the three Roman pillars of observability, why observability is critical in Kubernetes, and we're going to talk about Kubernetes native signals, metric logs, and traces and Kubernetes. And these are the three pillars. And then we're going to talk about observability stack and what are the best for Kubernetes. So again, as I said in the disclaimer, all of it's going to be particularly for Kubernetes, so we're not going to go in general. Of course, in general, there's a lot of stacks, a lot of tools, and multiple metrics, multiple logs, multiple traces. It's a very big, huge, actually, topic to talk about, and this is why we have only made it for Kubernetes for today. And then we're gonna talk about, or the practical part, as I said, is gonna be in index 8 and 7 and 8. I'm sorry. First of all, we're gonna have lab 1 or part 1, which is gonna be Prometheus for Kubernetes, and there we're gonna hop on Grafana for Kubernetes, which is a visualization tool. And then we're going to talk about maturity. So, how do we actually go from zero or beginner to an actual mature observability environment? And then we're going to give a small recap and say what's going to be next. So, let's start. What is observability? So, I don't like, as I always say in all of my sessions, I don't like to read off of the slides. So I'm just gonna show you this picture, basically. So we have two concepts. We have the concept of monitoring and the concept of observability. So as you can see, monitoring is basically a dashboard that makes us go wild. Maybe some things we don't understand. People just will put dashboards all over the place, even not even have the need to use all of them. So monitoring is basically dashboards. It gives us the metrics. It gives us the ability to see what's going on, but it does not tell us what's going on. We just see what's going on. So we can monitor that the CPU utilization is going over 70%. And we can see and check, no, so we can see only. We're not going to be checking for now. So we can see that maybe memory usage is spiking, the traffic is growing, and all of that is going to be related to monitoring. So اي شيء احنا بنشوفه، مثلا السي بي يو عندنا قاعد عم بيطلع، الترافيك قاعد عندنا عم بيطلع، رح يكون مونيتورينج، رح يكون عباره عن داشبوردز او زي رسم بياني هو بحكي لنا اي شيء. ولكن اذا بدنا نطلع على ايش نسوي or what are we gonna do about it, we're gonna deep dive more into observability. So let's give it like a very quick analysis, maybe, or a very quick example, a real life example, so we can like connect things up. So monitoring is the car dashboard. So if we have like check engine, we need to change the oil. If we have our handbrake up, on the dashboard of the car, it's gonna show us alerts or like some kind of signal that something is wrong. But if we want to check what's actually wrong, we have to observe. We have to open the hood of the car and check the engine. Okay, so this is the difference. Monitoring shows you, gives you alerts. Your check engine is on, and if you want to check what is the reason behind this check engine light that is on, you need to open the hood and actually check. So observability, you need to observe what's going on. So the three Roman pillars of observability, as you can see here we have the Roman pillars. So we have metric, logs, and tracing or traces. As we said, metrics actually give us the numbers, how much the CPU usage is spiking. Is it over 75%? Is it over 80% on the period of 5 minutes? So these are metrics اللي هي الأرقام. أي شيء له علاقة بالأرقام فوق ال 75% فوق ال 60% على فترة 5 دقائق 10 دقائق، هاي تعتبر metrics أو أرقام. But logs, on the other hand, tells us what's actually happening. So when we connect our car to a computer to check what's going on, it will give us logs. أو log هو عبارة عن رح يحكي لنا إيش اللي قاعد عم بصير. Like, is it 404? Is it, for example, a 500 error? Is it a 400 error? Is it a 300 error? Or is it 200 okay signals? All of these are logs. Logs will say like, we connected successfully to the server, or it's going to give us a 500 error, meaning there's a server internal problem. And the last thing we're going to talk about in the three pillars are tracing. So in AWS, we have a similar service called AWS CloudTrail. Yes, AWS CloudTrail. And it's kind of the same concept as tracing, in regards of tracing actually follows. I'll give you more of an example. So if you went to the airport and there's this officer who's actually tracing you, tracing every movement you're doing. So tracing is basically like maybe tracing the request from the beginning till the end to see where is it going. Is it doing the intended things it should be doing? So tracing is basically like stalking. But in a very good way. So it's stalking for the better purpose or the bigger picture. So on their own, metrics, logs, and traces, every one of them gives us some kind of story. So metrics give us like spikes in the CPU, in memory, in network, in packets. But okay, why is these spikes happening? We're gonna check the logs, and we can see that there is some type of attacks, let's say, and then tracing can actually get us the source of where an attack is actually happening. So every pillar can give us a story, but together will explain the full picture or the full experience, as you say. In Kubernetes, these three pillars work the same way, helping you understand system health, understand events, and follow requests across multiple services. And this is why each and one of them is important. And what's more important is having each and one of them together, working together hand in hand. Okay. Before we go to index 3, does anyone have any kind of questions? Or we can leave Q&A till the end of the session. Yes. Okay. Why? Oh, yeah. And I have this question that I have actually missed in index number 1. That what is observability? We explained that, but why is it more important than monitoring? So I would like you guys to answer that in the question. If you think it's more important, then say it's more important and why. If you don't think it's more important, say no and say why. So I'm gonna leave that for the chat. I'm gonna actually start. And I'm gonna write why is observability more important than monitoring. Wait, I wrote everything wrong. Okay. Hey, you guys, I wrote the question actually in the Q&A session, so you can guys actually take your time by writing it. Okay, so why observability is critical in Kubernetes? Well, as we said, Kubernetes in our previous session, in the last week's session, we said that pods are ephemeral. They can come and go, they can scale up and down, they can come, be generated again. It's not stable, as we said in the last session. And if you ever worked with Kubernetes, you're going to understand once a pod starts crashing, there is no way you can enter that pod and gain any type of insight. So, yes, we're going to talk about that Kubernetes always is trying to talk to you, but it's not always the case you can access it. So, if you, as I said, if you worked with Kubernetes in any type of way, once the pod starts crashing and loop crashing, there is no way you can get into that pod, get insights. So it's basically game over. Okay, so as we said, Kubernetes is powerful, but it also hides the complexity. And as we said in the previous session as well, we said that all Kubernetes methodologies is more about abstraction. So it hides these type of complexities on us. As we said, pods are consistently created and destroyed, services scale up and down, and when something breaks, it's often, as I said, you need to get into the service or into the server to actually understand what's going on. And as I said, once the pod crashes, there is no way you can SSH or exit into the actual pod. So without observability, failure will actually feel extremely random. A request is slow, a pod start restarting or crashing or loop crashing, or even users complain about it being slow or just complains. And while everything looks healthy to you, but there's actually something going on. Observability gives you the visibility into this environment, this dynamic environment, so it actually makes you understand what's going on. Even the pods can come and go, as we said. So logs will save all of that for us. Pods will give us it will give us the input from the pods, even if, as we said. So the last line, it's actually what matters. It's the essence of what we're saying in the whole session. Kubernetes hides complexity, but observability reveals it. So it's going to show us what's going on. So let's talk about signals. As you can see here, the signal right here. And as we said, that Kubernetes always is constantly talking. Even if you haven't installed anything, it's gonna talk. So if you try to get pods or describe pods, or trying to get the logs out of a pod, it will give you that if the pod is healthy. If not, if it starts to crash and to loop crash, it's not gonna. You can't enter and get you can't enter into the pod. But I think you may gain some type of logs or some type of observability signal. But even if you don't have anything like Prometheus, Grafana, Tempo, Loki, Jaeger, anything, it's still gonna talk to you. So it's built in Kubernetes. So it's gonna tell you if a Kubernetes is gonna tell you if a pod starts crashing, if it starts, it stops, and it's gonna keep restarting. It also shows you how busy is the pod, or each node is as well. And it also explains why things happen. So at some point, you're going to have some type of tool that will take those readings, those talkings from Kubernetes, and to make it make more sense to you. Until then, Kubernetes is going to talk either way, either if you have tools or you don't have tools. So you need to make it like, what they call it, DDDM, or data decision something making. So you need to actually understand these decisions, and you need to understand whether is this error happening because there is not enough resources, not enough CPUs, not enough memory, or there's something in an application code, or you can just like optimize anything, or maybe not just do anything. So basically, it's based on what the logs and traces are giving you. So the three pillars, or the three Roman pillars, which is metrics, logs, and traces in Kubernetes. So I'm not gonna go over them again. I'm gonna be very fast talking about them. So metrics in Kubernetes, metrics answer one question: how is the system doing right now? So is the node in capacity? Does it have good CPU utilization? Does it have good memory utilization? Does it need more? Or is the application taking the resources it needs? Is there a lot of resources we need to scale down? So everything needs to be taken in consideration. And metrics only answer one question: is how is the system doing? Is it okay? Is it extremely good? Is it we have a lot of resources we can scale down? So it goes both ways. Either we have too little of resources we need to scale up, or too much of resources we need to scale down. So it goes both ways. Logs explain the problem, as we said. So sometimes you can see that OOM for something, OOM killed. Maybe it means it's some type of error that Kubernetes shows. But practically, in my experience, OOM killed or error means that there is not enough resources in the pod itself. So we need to increase it in our YAML script. Traces answer the question: where did the request go? And as you can see here, we have the magnifying glass. It shows us the request flow when it goes from point A to point Z or to point B. Maybe there is something in between the workflow. Maybe something is not connecting right. Maybe there's a database connection, a microservice connection, a Java heap memory issue in the cluster. Yes, of course. And now we're going to go to index 6, which is the stack. So does anyone have any kind of experience with observability stacks? Do you know any kind of stacks?
I know one. If you want to answer.
you're the master of observability. انت الوحيد اللي كنت ماسك هذا الشيء بالشركه.
Yeah, exactly. So
Yeah.
well, we have actually another yeah, we have Muhammad, that's correct. We have a Cube Prometheus stack, which contains Loki, Prometheus, and Grafana, and we also have like ELK stack. It depends. Well, it depends on the company and depends on their business doing. So some companies actually prefer the Loki stack, which is called Loki stack because it contains Grafana, Prometheus, and Loki. Yeah, thank you so much, Christian. Yeah, it's actually it's right. OpenTelemetry, you can use it actually with Tempo, which is using Loki. We can you can actually audit the logs is coming from the code directly instead of the pod chill. This is actually very good. ELK also. Some people actually using Kapana and Elasticsearch. It depends actually on the needs of that business. So yeah, but there is actually multiple ones.
Yeah. And also, if the company is really investing into the maturity of observability, some companies actually would pay and get a New Relic. Yes.
New Relic, yeah, also New Relic is very good.
Yeah. And there's what's this thing we used? Greylog.
Greylog. Well,
Yeah,
Greylog is an amazing tool. هو صراحة كثير ممتاز جريلوج بالنسبة بالذات لموضوع الاوديت تبع اللوكس اللي جاي من الكودز.
Yeah.
بس مشكلة جريلوج إذا ما نعمل له سيت اب صح للأسف بياخد كثير ريسورسز. يعني تتذكري يعني اضطرينا نحطه على M5X large.
Yeah.
تمام. لا سوري 2X large عشان بس برضو كمان يسوي شغله صح.
Yeah.
برضو داتا لوج 100% سوري داتا دوج.
Datadog, yeah. Okay, Dynatrace.
Dynatrace.
Oh. That's
It's
new.
amazing tool Dynatrace. هسه حاليا انا بستخدمه بهاي الشركه اللي انا فيها هسه حاليا. I'm
Yeah.
using Dynatrace.
Yeah.
It's very good actually. يعني بالذات بالمالتي كلاستر. It's amazing.
Interesting. I'm gonna actually take a look at it صراحة.
Yeah.
Okay, so let's go more into CNCF native. Well, CNCF have Prometheus, Grafana, OpenTelemetry. These are CNCF native. So, what is the best stack? Stack, we actually had a very good discussion, and we talked about Loki, Tempo, or Jaeger, Prometheus, and Grafana. So I'm not gonna, I'm not gonna read off of the slides because it's the discussion we actually had right now. So Shahad, it's your turn. We're gonna go into Prometheus and Kubernetes and مسرحة.
مسرحي. هنعمل هون البراكتيكال بارت صح؟
Yeah.
Okay.
So wait, I think I need to give you access.
Just hold on a moment. It's gonna
Can you share your screen?
Yeah, definitely.
Okay.
بدي اروح. انا انعجقت بين الشاشتين. Give me moment. وين التيرمينال؟ هي اخونا بالله التيرمينال. طيب. شير سكرين. allow. ناخد هاي share. So before the session actually guys I installed Linux لأنه Linux الفيرتشوال ماشين لينوكس على هايبر في للأسف مش بزيادة، وفي عندك الفيرتشوال بوكس برضه كمان، بس فيرتشوال بوكس مشكلته كثير تعيس.
Yeah. WSL
هذا LTS. Yes, that's correct. هلا I think everyone have this lab, right?
Yeah, I'm gonna share. I've already put it in my GitHub, so I'm gonna share the link in the chat.
هسا ويك 3 هلا فعليا اللاب اللي حنستخدمه احنا اليوم هو I think انه بس عشان اتاكد من الكل everyone have installed the kubectl or kube control plane everything in cube.
Shahad, as well, you need to explain a little bit more about Helm because we haven't talked about it before. So we're gonna be using Helm, guys, and Shahad is gonna explain what is actually briefly what is Helm.
Yes. هلا Helm عبارة عن package manager. Okay, so it's a package manager specialized for Kubernetes. بفكرة أو the point behind it is simplifying the installation or upgrading of the complex of multiple applications. So it's based on reusable charts. So if you know like the package manager like on Mac, like we have brew, we have in Linux we have apt or yum. So it's actually does the exact same thing, but this is specialized للكوبرنيتيز. هذا اكثر شيء يعني هو عباره عن package manager فعليا.
And it's also CNCF native, so it's one of the graduated projects of CNCF.
That's correct. هلا في key concepts موجوده او جوا الهلم. في عندك الشارت هو عباره عن الباكج بيكون already pre-configured مع الكوبرنيتيز ريسورسز مثلا زي الديبلويمنت السيرفيسز سيكريتس وكلهم ديسكرايب باليامل. طبعا هون احنا كل شغلنا طبعا يامل، احنا ما فيش شيء احنا قاعدين نطلع برا ما يامل اكشلي. هلا في عندك التمبلتس هذول التمبلتس هذول عباره برضه كمان يامل فايلز. هذول انت بتستخدمهم للتشارتس بيكون في عليهم بليس هولدرز او بيكون هم عباره عن فاريبلز. ليش احنا بنستخدمهم هذول التمبلتس هذول؟ ان كيس مثلا اذا في عندك كستمايزيشن معين او ليتس سي مثلا واحده من الهيلم تشارتس مثلا باي ديفولت هو بينزل اس كيو لايت، بس انت ما بدك مثلا اس كيو لايت، بدك تستخدم ماريا دي بي او بدك مثلا تستخدم بوستجريس. هون انت مثلا تقدر تعمل واحد مثلا بوستجريس هيك انجن على جنب ويو كان بوينت الدي بي تبعتك using التمبلتس او الشارت تمبلتس عليه. في عندك الفاليوز اللي هو عندك اهم شيء اللي هو الفاليوز او الفاليوز يعمل هذا بيعطي سبيسيفيك كونفيجريشن للشارت نفسه. هسا اذا اذا بتفوت على اليامل او بالفايمل فايل بتلاقي مثلا شو التايب تبعه، او شو الكاين تبعه، شو هو، شو بالضبط انت شو بدك تحط له، بدك تحط له شيء شو كذا الريبليكا. هون انت بتقدر تحددها برضه كمان بالهيلم تشارت، او سوري هيلم فاليوز او الفاليوز يامل. انت هون you provide a specific configurations زي replica accounts, domain names, etc. to fill in the template placeholders. برضو كمان يعني chart templates والvalues هدول خلينا نحكي الكي كونسبت تبعون الهلم. so هدول بشكل بسيط هلم عباره عن باكج مانجر فور كوبرنيتيز.
اب ستور.
هاي يعني هاي abstract exactly.
نو الاب ستور او الجوجل بلاي تاع كوبرنيتيز.
Yeah, exactly, Philippe. Yeah, it's funny that you do everything manual in the Kubernetes when Helm clicks everything and gets easier. Exactly. But Helms actually is being graduated after the Kubernetes, so that's why like the old school people still using like the manual, say the manual method instead of using the Helm chart. But actually, I graduated from Kubernetes to Helm, so yay me. Okay, so let's go for the lab itself. So in this lab, at the end of the lab, you're gonna understand Kubernetes expose metrics natively, how Prometheus discover and scrape metrics, how Grafana visualize metrics and Prometheus, how cluster behaviors when visible without SSH. Because again, our main point for observing, like using like the Prometheus stack, is to monitor the cluster. And as Maya said, that when one of the pods like crashes, like a crash loop off, or mem, like because it's out of memory, there is a lot of like a lot of issues that can happen to the cluster without you knowing, which is actually it's very sad. And I think on the upcoming versions it's gonna be having the Kubernetes. I think I saw it in the incubation. They're gonna actually put in-house monitoring inside the Kubernetes itself.
Interesting.
Yeah, it's a huge leap, but I'm not gonna. I don't know how it's gonna take time. It's gonna take time, but if this happens, it's gonna be a game changer for everyone.
Honestly, Shahad, I don't think it's gonna take time because people are already using monitoring with Kubernetes. I think it's just gonna take more resources. So instead, you're gonna have to like expand your infrastructure so you can actually have it ready to deploy and use. That's what I think.
Yeah, exactly. So because already like we already have like the metrics is already being exposed inside the Kubernetes by default on the control plane, so there is actually nothing to do from our end, only just to point out to the correct endpoints, and that's it. And it's Kubernetes usually, like when you install any kind of stack inside the Kubernetes itself, by automatically or by default it's going to scrape anything inside that cluster. So when you have like multiple clusters and you have one Prometheus, or let's say one Grafana or one stack, that's gonna be like the issue, or the complexity is gonna be actually be bigger. In this lab we're gonna so this is actually a very good disclaimer, thank you Maya. In this lab we are not doing like any logs or tracing or any alerts or SLOs or production or any handling or security, because this is only focusing like how you are going to install Prometheus stack inside the Kubernetes. So this is going to be actually fun. Is everyone ready, just to make sure?
Yalla, proceed, Mr. Shahad.
Thank you. Thank you. So I'm gonna put this here for a moment. Wait. Oh, sorted out screen. Wait. Here you go. Terminal. So I'm gonna actually most of it I'm gonna do like copy paste. So, but I'm gonna explain it like while I'm going. Okay. So here's the first step is gonna be easy is to add the Helm repo of Prometheus is gonna add it directly. So whenever like you're gonna call it to install it on the cluster, it's gonna be there directly. So let's go just just copy the first line, which is this. This is actually gonna be available like anywhere. Like literally, this is like you can just ask Google like, hey, I'm gonna install like Prometheus Helm repository. How can I do it using Helm? You're gonna get actually the exact same thing. So here I'm gonna paste it. So I'm gonna be here, and Helm is not installed. Nice. I have no idea why it's not installed.
But that's perfect. Actually, we haven't said that it's a prerequisite to install Helm.
And yeah, actually, I didn't do that. Give just one moment. Install Helm really quick.
So, guys, a prerequisite you need to have approximately like 3 things. So the first thing you need to have is Minikube or some type of operator. You need to have Docker engine. Either it's Docker desktop, Docker CLI, or Kolema. I use Kolema for my Mac. And you need kubectl or kubectl or kubecli. And then the last thing you need is Helm CLI. So you need, I said 3, you need 4 things actually. Sorry. Add classic.
Classic,
The-
yeah, exactly. Up. Sorry. And yeah. Like there is already a script here is already like completed. I don't know, like I can show you guys here. Like I simply just googled how to install Helm Ubuntu 2020.04 and that's it. It's just gonna give you like the answer here right quick. I just installed it. The installation here is actually from using scripts, so you can install it directly. You can install a script, but I installed it here using the script because the script itself contains like multiple steps that you need to use, like move the installation file to local or this directory, this one. So you need to move it. The script is gonna do it for you. It's gonna also do the curl. It's gonna do everything for you. Just like you run the script and that's it. Okay, so let's try using Helm right now. I hope this time it's gonna work, but let's see.
Okay, المشكلة the problem
Did
is
I?
with the GitHub.
Yeah. I got it. No. I know what's the issue because it's not copying all of it like on a single line, so that's why. Up. Here you go.
Oh my god.
Yeah, I know. Sometimes this is like frustrating with Linux. Happy Helming. Okay, so what we do right now is added the Prometheus community chart here, like on our devices, so we can install it inside the queue. So let's first. So I think we're gonna create a new space.
Yes, to isolate.
Called monitoring. Yeah, just to isolate it. Yeah. So right here, namespace monitoring has been created.
Yes.
So if we're gonna go kube control, then get an S. As you can see here, we have multiple ones. Default is installed by default, and these are being used by the control plane and the rest of the Kubernetes controls. I think the kube public is controlling the APIs, as far as I know. Yeah, but here we're gonna install like monitoring. So right now it's being active, which is good to go. So why we're using namespaces again? We're gonna namespaces. We just isolate, as Maya said. We isolate the programs, anything we are installing inside the Kubernetes, so we can isolate it. So we don't
Yes.
anything like going to the default, or we don't anything going to be messed up. So that's why we are using namespaces. And as you know, the namespaces is a whole new network for that applications. So we're gonna go and install. I'm gonna write it actually down. That's gonna be much easier for me. Install KPS Pro me. I'm just gonna copy it. Great.
I think, Felipe, the metric server is actually included in the Helm. Helm actually like grips everything together.
Dash dash monitoring dash set. You see this? You see this, guys? This is set grafana.admin password actually
Please,
equal
what?
admin123. This this is called this is like one of the annotations that you can use inside the value YAMLs. Like we spoke on the Helm, the YAML values. Actually, you can set a couple of values or a couple of annotations inside the YAML while you're doing install. So you can set it here like directly. Hey, I want the admin user or the admin password is going to be admin123. I can just add here a couple of variables here without actually editing the values YAML. I can just use it or using the terminal. So it's gonna get in set grafana dot admin password. It's gonna be equal admin123. Just wait for it. These warning actually is not that important. It's only warnings. It's, as you can see here, it's gonna be synchronized format. Also, a lot of this is gonna be ignored. This is not an initial for the setup itself. So as you can see here, it's installed here, name KPS, last deployed here, namespace is monitoring. The status is deployed. So this is one of the main, this is one of the main indications that to make sure that it's being actually deployed. Notes here, as you can see, Kube Prometheus stack has been installed. Check if, and then you can see here, Kube control here. I'm just gonna grab this one and paste it here. So it's gonna show all, I'm sorry, get pods. So as you can see here, this is all the containers that we have, all the pods that we have. We have alert manager. Usually it takes time actually to initiate. Also the Prometheus stack itself. But we have actually a couple of things actually being running. We have the operator itself. So the operator is going to be, as Felipe like asked his questions on the chat, it's being actually installed here. So as you can see here, the operator is installed here. Also, the node exporter is being also deployed here, and for the metrics, the metrics is also already installed here. So we just did like a quick grab, and everything is running, which is actually very good. So we need actually to access Prometheus. So the one of the commands can use in the kube control is the port forward. So what is port forward? You're only port forwarding from the cluster itself to the local machine that you have. So if you go to kube control, then port forward, then slash and monitoring, then SVC, which is service. Yep, KPS. I was gonna actually copy it again. It's gonna be much easier. Yeah, stack dash. I was gonna. Yeah, I'm lazy. Copy.
Understand.
Guys, I'm really great. I'm really lazy.
Yeah.
I'm just. Okay, so the port forwarding here is started. So if you want to actually go to here, I'm just going to go to localhost and drop the 1990. So as you can see here, this is the Prometheus. So Prometheus is here actually is going to do like a lot of things here. So let's say you have like multiple applications installed on a different or multiple namespaces. All of them, since you installed Prometheus and Grafana inside the cluster, it's gonna be already scraping itself. So you don't need actually to do like any exposing for like a port or an endpoint or a metrics to Prometheus, because it's gonna auto scrape it automatically without doing anything. Wasim, completion for Helm slash cube control is really helpful.
Yes.
Can
What do
you
you
put
mean
that
by
on?
what do you mean by completion?
Can you just explain more, please, Wasim?
His name is Wissam. I did the same mistake.
Wissam, I'm so sorry, man. Okay. Okay. So it's an auto-completion script for Bash. Oh, that's nice. Actually, I love it. Actually, I'm gonna keep it. Actually, we're gonna keep it actually on site. Yeah. I got it. Yeah. I'm just looking over the documentation right now over Helm. But I'm an old school guy, so that's why I used the method actually inside the. Yeah. So, but thank you so much. Thank you so much. Actually, I'm gonna actually review this documentation. It's actually very helpful. I'm gonna actually use it like later. So thank you so much. Okay. So as you can see here, like we have like multiple. I'm just gonna go the dark mode. Come on, thank you. So as you can see here, we have multiple actually tabs we can go. Like this is the query. This is, by the way, it's called QL. So it's gonna using PromQL. This is something specifically for Prometheus. So if you have like anything graph or table, you can just execute it directly. You can here explore metrics. As you can see here, this is all of the type of metrics you can expose, and you can use it inside the query itself. So if you know like exactly what you're looking for, yeah, you can use here the query. You can see here the alerts. Yep, as you can see, there is like we have one of the alerts is member down. Some of these, yep, it's firing. Yep, these are something you are using it or you see it inside the Prometheus, because once you're using Grafana and you set the Prometheus as a database, data source, everything is gonna be automatically moved from Prometheus to Grafana, and you can visualize it. Plus, you can actually set alerts there, because here Prometheus is only doing the scraping and only put all the logs and the alerts here, but you are not defining the alerts or defining the thresholds. So it's saying it's down, but actually it's not down. I'm working on it. Yeah, so there's a couple of little, like, see, like there is like a couple of alerts you're gonna see. It's firing automatically without you actually intervening, even if there is nothing wrong actually in the Kubernetes, because this is an alert means to ensure the entire alerting pipeline is functional. So that's why this alert is always firing. Therefore, it's always should be firing an alert managing firing at receiver. So, but when you install actually Grafana, you're not gonna see this, because by default it's gonna say this is a watchdog. Yeah, hey, this is actually firing. Not don't actually scrape it or don't put it there. Any node. By the way, you can install like multiple plugins on top of Prometheus. So we have like black box exporter. Black box exporter usually is heartbeat check to the websites or anything that you actually do. Then it's gonna come back with the results and how much it's taking time to process and how much time there is any latency. it's not installed by default, you can install it actually here on the Prometheus. You can use it as a sidecar container, or you can use it actually as a separate pod, so you don't use it actually inside the Prometheus itself. So there is actually multiple ways you can do it. It depends actually on the business need, but as Shahid, I prefer actually to separate everything. So we have Prometheus, just Prometheus pods, we have Loki's pods, we have Grafana's pods. Even if everything is inside on the same name monitoring, that's fine. But I prefer everything is separated, because some pods or some site container depends on the original containers to be started up. But if the original didn't started up, the sidecar is not gonna be started. So that's why. We have here the status. So you have two sections. We have the server status and we have the monitoring status. The monitoring status is actually anything related inside the cluster beside the Prometheus itself, and the server side is anything regarding the nodes. So as you can see here on the matrices, you can see there is a lot. So this is the scheduler is not on. See, as you can see, it's already pushing like some alerts. So as you can hear, stack, the control manager is not reachable. This is not reachable. All of them actually is working, but it's I need to do some like networking routing, so everything's gonna be fine. So, but I'm not gonna do that. But let's say if you are using it on a real time or a real cluster, this is not gonna be the problem, because usually when Prometheus is running, it's gonna be running without any issues. We have the rule health. This is some rules are predefined by Prometheus itself. This is usually for the cluster and some installed Helm charts. We have the service discovery. This is the service discovery. This is the endpoints is being discovered automatically by Prometheus. So if you exposed like one of the, let's say if you've exposed one of the exporters inside the cluster, there's going to be automatically skipped by Prometheus. But what if you exposed an operator outside the cluster? How are we going to do it? So inside also the Prometheus, you can set like endpoints, and these endpoints you can add it from the other side, and it's gonna once it's picked up here, it's gonna restart Prometheus, of course, because you do some changes, and from there the exporter is gonna be exposed. So some services are being exposed directly, automatically. Some of them are not. So it depends again how the setup that you have. But right now, since we are talking about local and everything is local, you don't need like anything fabulous so to run it. But actually, it's running beautifully without any issues. So let's go back to the lab itself. So as you can see here with the statuses, targets, everything is up. We saw that. So as we said, that this stack is not only installing Prometheus, so it's installing Grafana, Prometheus, and Loki, and also you can install them separate. So you're actually using the same values YAML or the deployment YAML. So yeah, you can use only like installing one at a time, but you're gonna actually not install anything like this. Is like at least the base, so you can build on it. So sometimes it's actually much easier to deploy these threes than just to deploy it separately. So let's go access Grafana. Hey, this is one line. Nice. And here we go. So we're gonna go to localhost. Oh, by the way, this is the default. So there is actually a couple of default ports for Grafana and Prometheus. Prometheus is 9090. Grafana is 3000. So let's go to the Grafana. The username is admin by default. This is regardless of which version of Grafana actually you are using. And the password, we are set it up during the process or during the installation. So we're going to go admin123. So So you can see here we are inside Grafana, but I was gonna actually to check something. Yeah, here is it. So the data source by default is not being put. You can do it actually using the YAML file and saying, yeah, hey, I have Prometheus is already installed, and this is the host name of it. So you can use this as a data source before installing actually. What is it again? Yeah, Prometheus. Thank you. Okay, so
But if you
let's go
check,
ahead.
wait, Chad. If you checked, if you configured data sources, would you like see if it's actually, because it would make sense if
Actually,
all of
it's
it
there.
was. It is. It makes sense to be connected because we deployed it together. It needs to be connected together.
Well, yeah, but no, actually, I did like a couple of Grafana's deployment, like it was separately, not within the stack. So that's why the data source is not being scraped automatically.
Yeah.
How to integrate with a Grafana Cloud and will require to use it? Actually, no. So for a Grafana Cloud, you don't actually necessarily to use it. You can just deploy it here inside the cluster, or deploy it actually inside a VPS. So it's not necessarily inside the cluster itself. But we deploy it inside the cluster itself because it's auto scraping everything. So as you can see here, I already installed the stack, and the alert manager and Prometheus has been set as a data sources by default, and I didn't actually do anything for that. For a Grafana Cloud, yeah, definitely you can use a Grafana Cloud. It's gonna be more complex because you are exposing a couple of endpoints just to make sure that it's actually it's there, because you're gonna install the Prometheus, let's say, inside the cluster, and you have Grafana on the cloud. So you're gonna just make sure that you have a URL or an IP address for that Prometheus, so you can actually connect to it. So if it's not connect to it, the Grafana is not gonna see any type of actually operator, not just only Prometheus. Grafana Cloud is actually great. You can use it when you have a lot of accounts, or you are a company of IT services and consulting. You have multiple clients, and you need just one portal actually to sign in to see all the performance for all of them. That can work. Or you can use the same concept of a Grafana Cloud and install it on prem or something on cloud on something in your infrastructure, and you can use it the same method.
Yeah.
But Grafana Cloud has actually much more features. So Grafana, or the open source Grafana, it's open source, but the community version of Grafana and Prometheus actually does not have AI. Grafana Cloud actually does have AI. This is actually a very helpful step actually for the logs. Yeah, but I actually this is one of the main differences between the Grafana Cloud and the Grafana community. So we accessed the Grafana. We checked it's actually connected and confirmed because we installed Stack. So everything is going to be done automatically without doing actually anything from our end. So let's explore a couple of dashboards. Actually, I love the dashboards. So as you can see here, there is a lot of dashboards. Actually, it's already pre-installed, which is good. Some of stacks actually, because this is there is actually a lot of sources for this stack. You can use the official one, and some people actually modifying their stack, so it's installed, pre-configured, and everything is being done, including the dashboard, like this instant. So let's see. I'm gonna actually see the networking side of that. So all the namespaces. No, I'm just gonna include this. So let's go for Grafana overview, maybe. So this is a Grafana overview dashboard. This is already pre-installed and predefined. But let's say you want to do a new one. You can actually make a new fully from scratch, everything. But it's gonna actually take a very time and a good chunk of ChatGPT, so you can master it. Trust me, I mastered ChatGPT with Prometheus or PromQL, and it was a disaster. So If I find something already predefined on the dashboard, use it. If it's actually is gonna be capable of doing everything, yeah, just use it. So I'm actually doing like an import because doing a simple dashboard is gonna take time. For the sake of this event, so I'm gonna do like I'm importing something. So Grafana dashboards, or there is actually called something grafana.com/dashboards. You can just go for it and install a couple of dashboards. Actually, this is amazing. You can, Maya, what dashboard do you have in mind, like just for sake of testing? Like there is a feature or a metrics that you want to بدك
I
تشوفيها
don't
او
know,
بدك تراقبيها.
maybe pods لأنه إحنا بدنا like نحط الpods or something.
Yeah, pods مثلا هي في عندنا مثلا كي اس داشبورد مثلا. اوكي طب انا بدي اشوفها مثلا هاي الداشبورد. انا بالعاده باجي باخذ رقمها من هون اللي هي 15661 بعملها كوبي وباجي بحطه هون دايركتلي. بعمل هون للود للاي دي ترى it directly imported the dashboard. هون some dashboards requires a data source to being operated. So you have Prometheus here. We already have a Prometheus, so I'm gonna select it and import. Ta-da! I have all of them right here. By the way, if like this is like the CPU breakdown, because again this is locally installed, so there is a couple of features gonna be not being visible like 100%. But as you can see, this is like the node information. I already have like, see here, Minikube. I have limit of 110. I have 13 bots right now. I have the total and everything. So let me just expand this so you can see it better. This is one of the dashboards. And by the way, you can absolutely edit anything on it. So let's say I'm going to edit nodes with pods. So I'm going to edit here. You can see the PromQL they were using actually for this dashboard. So you can see the metrics browser count. This is the kube config onf. Node info. Original Prometheus. This is the same thing. This is created by kind. If there is like we have any jobs, this is for pods. You can actually add another query. You can visualize it on anything that you want. So that's the beauty of CNCF projects. It's open source. You can use whatever you want on it, even if it's not something specifically for Kubernetes. You can use it. By the way, there is a lot of actually companies using Grafana only just to visualize dashboards, and it's not actually being using on the cluster, which is actually amazing. So we're gonna see like what kind of data sources like we have. Actually, we have a lot, and there is actually a lot of plugins actually you can install on Grafana, and you can use the UI for it, which is actually amazing. So we have Loki here. We have Elasticsearch. Even if you are using ALK, you can actually add Elasticsearch as a data source here. We have Tempo. Tempo actually is equivalent to Grafana. We have MySQL. You can use an SQL as a data source. You can monitor the SQL directly from here. Also, like you have MS SQL. You have Postgres. You have Cloud. You have CloudWatch. I used CloudWatch actually on Grafana. It was amazing, but it was so much cost. Also for the Azure monitoring. So if you know what you are doing here, use it. But if you're not, please don't, because it's so much cost. Actually, one of the months, actually, I just one of the months actually, Maya, for CloudWatch alone, it was like 2K a month.
No, don't tell me. After you left, it went up to 8,000.
Exactly.
Yeah.
CloudWatch actually, or one of the cloud monitors, it's actually is very cost, so you need actually a constant monitoring for it. So
You
please
need to
be
remove the
please be
retention.
careful, guys. Please be careful, guys.
You need to remove the retention period. Yeah. You need to
Yeah,
add a
exactly.
period actually.
So
We can
let's.
do Shad. I think we can do the demo later because I think we need to wrap up the session. شو رأيك؟
Yeah, sure. Yeah,
Sure.
but yeah, of course. So basically, this is how like you install Prometheus, Grafana, and Loki stack. It's being installed, as you can see. It's very easy. There is
Yeah.
actually nothing much. Actually, it's not that hard actually to install it. The only thing, or the only hard thing actually, is how to use it properly,
Yes.
how to set up the alerts properly, how to use the dashboards properly, how to make sure that if there is an alert is being actually communicated right. You can use like via an email or via Slack channel or via Teams channel. So again, sky's the limit. You can literally do whatever you want, actually do it, but just be careful.
Yeah.
These type of observability, even if it's not doing actually anything, sometimes actually it hides something. So just be careful.
Yeah. And make meaningful dashboards. Please don't just go around and put dashboards left and right. Actually, do
Yeah,
dashboards that's meaningful and you're actually gonna need it. This is very important.
that's correct. Yeah, that's correct. I think that's it from my end, Maya, for it. I hope that we have like more time,
Yeah.
but yeah, we can just like we can do like the demo later. So more than
Well,
okay here.
thank you, Shad, so much. You have given me as well a bunch of new insights, and it just made the whole thing very much simpler for me. So I would guess it have made a very nice and clear presentation.
No problem. It's my specialties, and I love explaining what is my specialty. So yeah. Thank you so much, Christian. Abdo, yes, actually, there's this actually session is recorded, so you can go to cncf.io and you can just watch it from there. And I think there is an email actually being sent to all of the attendees, so they're gonna say the review or the recap, right?
Yeah, I think, and I also like upload it on my YouTube channel, so it's
Yeah.
gonna be
So
uploaded.
please subscribe to the tech stuff also. It's an amazing actually channel, YouTube channel. You can learn a lot of it.
Thank
It's being hosted by Maya. So please do.
Thank you, Shad.
Could you please share the link, Maya,
Yeah, yeah, of
on it,
course.
please? And I think you already uploaded the rest of or the previous events also on the same
Yeah,
channel, right?
yeah. Okay, so the last thing I'm gonna be. Thank you, also Sam. So the last thing we're gonna be talking about in this session, and I would think it's the most important. It's a very important topic as well. وهو موضوع كتير مهم اللي هو for monitoring to observability maturity. So we have seen Shahad doing the actual lab. You can see it's so much easy and anyone can do it on the local setup or on the cloud. You can upload it on EKS using a daemon set. You can the possibilities are endless, but you need to understand something, and it's always the case in everything, not just in observability in Kubernetes, not just in any DevOps. Doing it locally does not mean in any kind of way it is production ready. So production ready, it's on a whole different level, and this is what we mean by observability maturity. So what Shahid did is an action. It's a very easy understanding. It gives you the steps to do a production ready setup, but it's not production ready setup. So we need to understand that we have 4 levels of production setup. So the first thing is you need to understand basic metrics, the metrics that you need, the CPU utilization that you need, and everything that goes with it. So you need a very basic understanding of metrics. I don't think it's just basic. You actually need a very good understanding on metrics. And then you would need to understand logs and dashboards. As I said multiple times, you need to know what kind of dashboards to put and to utilize, not just throwing around dashboards left and right and just cranking up the space of Grafana. So you need to actually make sure that the dashboards you're using and deploying actually make sense to the business. And reading logs comes with experience. It comes with as well even ChatGPT. I personally use ChatGPT for reading logs, but even
Yeah, me
ChatGPT
too.
yeah, we all do. Come on. It comes with experience, actually, just
Yes,
looking at the log and then solving the problem.
exactly. لا, yeah, but since if there is like a ton of log trace,
Yeah,
yeah, it's gonna be headache like just to manually. This is like one of the AIs actually benefits you as a DevOps.
yeah,
Yeah, to do or at least to do logs, even if you do like a custom AI with the system or a proper system prompt that it can go
yeah.
and analyze the logs and give you actually what is the next action. And this is one of the projects actually I'm working on using
Yeah.
local AI.
But it's still a very good disclaimer. Yes, Philippe, if you understand the result, there is no shame.
No
Still,
shame, exactly.
still, the AI wouldn't give you a definite answer. So I had this problem once. I'm just gonna say it very quickly as an example. I've tried deploying a self-hosted Bitbucket runner to use a CI/CD pipeline, and then Gemini actually told me to kill the process. And then when I killed the process, I just deleted the whole Bitbucket runner, and I had to regenerate it again from the UI because it has like account IDs and stuff that you need to like configure before actually using the self-hosted Bitbucket. So it's because of Gemini I actually deleted the process, so I killed the process, and then I had to redo it again because he gave me an actual wrong instruction. So you actually guys need to be careful while using logs. You need to make sure you're not using sensitive info. So before just copying and pasting your logs, you need to remove any kind of info with example, number, any type of any different things, or just removing the actual sensitive data. Yes. And you need to like make sure of everything before just throwing your stuff around on ChatGPT or any kind of, even if it was an organizational AI, they still can read patterns, they still can read interference. Yes. So as we said, the first thing, basic or level 1 is basic understanding of metrics. Level 2 is logs and dashboards. Level 3 is traces and correlations. So not everyone has the ability to use traces and understand tracing and how it goes. So if you understood logs and dashboards, you can go to the third step, which is um, traces and actually correcting the mistakes that you are doing or the application is doing as you go. And then level 4, which is actually one of the things that are more important, is being proactive. And you can be SLO driven, so you would need to actually understand user experience. Is the process is being very slow, is it being very fast? I don't think being fast is an actual problem. I think being slow is the actual problem. So
Yeah,
you need to actually be proactive, so every time an alert or something happens, you need to take action and to understand. Yeah, event pillar would actually be understand. So we're gonna go quickly through the recap. So we asked a question, which is why observability matters, why it matters in Kubernetes, and why it's more important than metrics. Maybe it's not. I'm gonna leave that to you guys to guess and answer. And we've talked about the 3 Roman pillars. Always keep in mind 3 Roman pillars: metric, logs, and traces at a very high level, and how it relates to Kubernetes. We also gave a very detailed, thanks to Shahad Lab and
of
Prometheus and
course.
Grafana for Kubernetes. And then we've talked about the maturity of understanding what goes on and production setup, and that's it for today. So what's next? In week 4, we're gonna have Kubernetes for business. We're gonna understand. We're not gonna talk a lot about cost because we have another session, which is session number 6 with Christian, and it's gonna talk about why Kubernetes costs more than you expect. And this is gonna be detailed as he's one of the brilliant minds in FinOps as well. So
FinOps.
yeah, Christine is the mastermind behind FinOps. Yeah, I think unfortunately, yeah, he's still with us. I thought he left, but we're gonna talk about more about
I'm
Kubernetes.
here. I'm here.
Yeah, Christian is here. Yeah.
Yes, but I'm not an expert. I'm not an expert. I will just share my experience. That's all.
As I told you before, you told me that, and I'm telling you, well, not everyone just understand the basic of this. So I will call you expert because I saw your work and I appreciate it. So you are an expert in my eyes.
Of course. I will share my experience. I will share my experience as far as possible. Thanks.
Let me stop the recording.